So we've talked about standard forms of lines, and those come in what we know as this ax plus by equals c form, and there are some specific ways to represent that where we know a, b, and c are all integer values having a greatest common factor 1. We're going to look today at something called a slope-intercept form. And those of you who've seen some algebra before are pretty familiar with this. Slope-intercept form, basically, rather than having ax plus by equals c, isolates y. So what we have is we have an isolated y equaling some mx plus b. M represents our slope. B represents our y-intercept, where our line crosses the y-axis. And x and y are just coordinates. Okay, they're part of a point on that line. So if I now take a look at a problem like this where I'm asked to write a slope-intercept equation where they give us the slope, this is our m value, and they give us our y-intercept, which is our b value, and we're looking to write some y equals mx plus b, we're just filling in what we're missing. So we have y equals 4x minus 10. We leave the x and the y as variables in this case, and we always, if we want to write something in slope-intercept form, solve for m, solve for b. And once we've done that, we've written it in slope-intercept form. Pretty standard, basic equation. When we're asked to actually graph these things, the idea is to identify what the number in front of the x is, because that will be our slope. So in this case, our slope is 2/5, which means our rise will be 2, and our run will be 5. And then our y-intercept b is equal to -3. So in order to graph this, I move on my y-axis down to -3, put a dot, and from that point I do a slope. So I go up to and over a total of 5 from there, put another dot, and if I wanted to, I could do it again just to, have a straighter line, if you will, or connect more points. I can go up to, over 1, 2, 3, 4, 5, put another dot there, because the slope's going to be the same everywhere on the line, and then connect those dots throughout, and I've got a line with a slope of 2/5 going through -3 on the y-axis. Here's another one just for practice. In this case, my b value is +4. My m, or my slope, is a rise of -1 and a run of 3. You'll notice this negative is in the middle. You could either choose to have that negative on the bottom or on the top, but it can't be on both, because then a negative over a negative would be a positive. I like putting the negative in the top part, so that tells me to go down first. So what I'm going to do is go up to 4, 1, 2, 3, 4, put a dot there, and then the slope tells me to go down 1 and to the right 3. So if I go down 1 to the right 3, I can do that twice if I wish. I could even go up 1 and back 3 if I chose to put the negative on the bottom. Put that there, then connect the dots, which I did pretty poorly, but you get the idea. And there's my line. In this case, it doesn't look like we have a rise over a run, but we actually do. This is our slope right here, and here's my y-intercept here. My slope in this case, 3 can also be expressed as 3 over 1. So we have our rise here, 3, and our run of 1. So from -7, 1, 2, 3, 4, 5, 6, 7, put a dot, and then I move up 3 and to the right 1, up 3 to the right 1, connect the dots. Likewise here, we have a slope of -4 and a y-intercept of 1. Negative 4 can be written as negative 4 over 1. So that's our rise over our run. This tells us to go down 4, to the right 1. And we'll do all that starting from positive 1 on the y-axis. I go down 4 over 1. Do it again, go down 4 over 1. And there's our graph. Now in this case, you'll notice y is not isolated, so I don't have this in slope-intercept form. I'm going to do that. And I've got a couple of ways I can do it. I could choose to bring the y over to this side to keep it positive. I'll just leave it right here and subtract 4x from both sides. Notice I don't have like terms though on my right side, so I'll have negative 5y is equal to, I like putting my x term first, negative 4x plus 10. Now I need to isolate the y, so I have to divide both sides by negative 5, and rather than dividing the whole side, I divide each individual term by negative 5. In so doing, I get y is equal to negative over negative is a positive, and positive over negative is a negative. And so here's my slope, here's my y-intercept. I go down to 2, and I rise 4, and I run 5. Do it again if I wish. Up 4 over 5. Connect the dots. And there's our line. Again, we've got a case that's not in slope-intercept form. I need to get y isolated. I notice I have fractions all over the place. I'm going to go through and clear the fractions first off. Multiply everything by 6. When I do that, I end up getting 3 on the first term. 6 and the 3 reduced to a 2, and 2 times 2 is 4. And I end up with 6 here. Now notice I didn't isolate y yet, but I've gotten rid of the fractions. So now I'll go through the same procedure I did last time. Subtract 3x from both sides. Pay attention to like terms, so I have 4y is equal to negative 3x plus 6. Divide each side by 4, and I choose to divide each term by 4. So negative 3/4 x plus 3/2. Now this is a little bit different because my y-intercept is a fraction. My slope's pretty much always going to be a fraction, but when I have a fraction for my y-intercept, you're doing your best effort to estimate where 1.5 is. And in this case, when I go down 3 and to the right 4 for my slope, I'm going 1, 2, 3 down. So you'll notice that this distance ends in a half spot, and then when I go 4 over, I'm going kind of in the middle of these cross sections and putting my dot there. I go down 3 again, 1, 2, 3, over 1, 2, 3, 4. Again, you'll notice my dot does not go on an intersection, it goes in the middle of the square, and I connect the dots. So this is a little bit more of an estimation because you're not going through exact values, but it's a pretty good representation of the line. Now this next example, I have two kind of special cases. This is in y equals form, but there's really no mx plus b. In fact, there's no x. What this says is y is always 5. So if y is always 5, then I go to the y-axis, and I put a 5 there. Then I say, well, where else is y 5? Well, y is 5 here, it's here, it's here, y is 5 over here. So this ends up being a horizontal line. It doesn't fit necessarily the slope-intercept form. Likewise, this says x is always -3. So where's x -3? X is -3 on the x-axis right here. But it's also -3 here. It's -3 here, here, etc., etc., etc. So this is a vertical line. Now, we've talked about slopes before. This is said to have a 0 slope. And again, we remember that because the z in 0 has a horizontal line going through it. And this is said to have no slope. In other words, it's undefined. And we can tell that by the line in the end goes vertically up and down. So now what we're going to do is, rather than graph the equation, we're going to write the equation from a graph. So the key thing in these problems is to make sure you find an exact point that the line goes through. So you can see the y-intercept is clearly 3 in this case, and it appears that it's going through this point, etc., etc. So to find the slope, I need to figure out how much I rise and run from one point to another. So you'll notice here, if I go up 1 and over 2, and this is a positive slope since it continues to rise, that's going to be my slope. So I have y is equal to, my slope we just said was up 1 and over 2 x, so here's our m, plus my y-intercept, which we just got done saying was 3. And there's our line in slope-intercept form. The last example, we'll do the same thing, except in this case, we have a negative sloping line because it goes down as I move from left to right. And we notice that our y-intercept, remember we're trying to write y equals mx plus b, our y-intercept in this case is 6. Now I need to find another point that this line goes through. It appears that there's, I've actually drawn them in. There's one here. And this says it's a point, but I can't tell the exact point. This appears to go through a crosshatch. And this appears to go through a crosshatch. And let's see if the slope's the same. If I move down 1, 2, 3, 4, and over 1, I get to that point. If this is the slope, then I should be able to go down 1, 2, 3, 4, and over 1 and get to that next point. And I was able to, so the slope is the same everywhere on the line. And in this case, it's down 4 over 1. And if I wanted to rewrite that, I could just say that's -4x plus 6. And there's the slope of the line and the equation written in the slope-intercept form.